Hello everyone. In this video we will discuss about classical probability. Before we get to the main topic, let's start with what is probability. Probability is a measure of the possibility for an event to occur in an experiment carried out under certain conditions. Each possible outcome of an experiment is called an outcome. The set of all possible outcomes of a statistical experiment is called the sample space. For the example, tossing a coin S equals M and B. And the next is events. An event is a subset of the sample space. The complement of an event with A respect to S is all elements of S that are not included in A. The intersection of two events A and B is denoted by A intersection B, is an event whose elements are included in A and B. Events A and B are mutually exclusive or separate if A intersection B equals an empty set, that is, if A and B do not have a common element. The combination of two events A and B, denoted by the symbol A union B, is an event that contains all elements belonging to either A or B or both. And the next is Venn diagram. As you guys can see in this picture, have the example of Venn diagram. In this picture, there are example of A subset B, A intersection B, A union B, and A intersection B equals an empty set. The next is combinatorial, calculating sample points. If an operation can be performed in N1 ways, and if for each of these ways a second operation can be performed in N2 ways, and if for each of the two ways the operation can be performed in N3 ways, and so on, then a series of K operations can be performed in N1 times N2 times N3. Example: what is the sample point in the sample space if two dice are tossed once? The first dice can yield N1 equals 6 positions. For each of these positions, the second dice can produce N2 equals 6 positions. So the pair of dice can produce N1 times N2 equals 6 times 6 equals 36 positions. Next is permutation. A permutation is an arrangement that can be formed from a collection of objects that are taken partially or completely. For example, take three letters A, B, and C. Permutation that can be made: ABC, ACB, BAC, BCA, CAB, and CBA. There are N1 equals 3 choices for the first place, N2 equals 2 for the second place, and leaving only N3 equals 1 for the third. So the number of permutations that can be made by three letters 3, 2, and 1 equals 6 permutations. The number of permutation of n different object is n factorial. The definition: 1 factorial equals 1 and 0 factorial equals 1. And the next is combination. Combination is the number of ways to choose are objects from a number of n regardless of the order. The number of different combinations and objects when taken r at a time is, as you guys can see, the formula of combination. Now, let's get to the main topic of our discussions. What is the classical probability definition? Classical probability is the statistical concept that measures the likelihood or probability of something happening. In a classic sense, it means that every statistical experiment will contain elements that are equally likely to happen or equal chances of occurrence of something. Formula for classical probability. The probability of a simple event happening is the number of times that event can happen divided by the number of possible events or outcomes. As you guys can see the formula, where PA means probability of event A. Event A is whatever event you are looking for, like winning the lottery, that is event of interest. And F is the frequency, or number of possible times that event could happen, and N is the number of times the event could happen. And for example, the odds of rolling a 2 on a fair die are 1 out of 6. In other words, one possible outcome, or there is only one way to roll a 1 on a fair die divided by number of possible outcomes. When you can use the formula, you can only use the classical probability formula when all events are equally likely. Choosing a card from a standard deck gives you a 1 of 52 chance of getting a particular card. No matter what card you choose, King of Hearts, Queen of Spades, 3 of Diamond, or other. On the other hand, figuring out will it rain tomorrow or not isn't something you can figure out with this basic type of probability. There might be a 15% chance of rain and therefore an 85% chance of it not raining. Classical probability cannot be used. Dividing the number of events by the number of possible events is very simplistic, and it isn't suited to finding probabilities for a lot of situations. For example, natural events like wake, height, and test scores need normal distribution probability charts to calculate probabilities. In fact, most real life things are simple events like coins, cards, or dice. You'll need something more complicated than classical probability theory to solve them. And the next is classical probability examples. For the first examples, the typical example of classical probability would be rolling of a fair dice because it is equal probable that top face of die will be any of the 6 numbers on the die. There are 1, 2, 3, 4, or 6. The second example, another example of classical probability, will be tossing an unbiased coin. There is an equal probability that your toss will yield either head or tail. And the third example, in selecting bingo balls, each number balls has an equal chance of being chosen. And the fourth example, guessing a multiple choice quiz. Test with, say, 4 possible answers A, B, C, or D. Each option or choice has the same odds or equal chances of being picked, assuming you pick randomly and do not follow any pattern. There are many other examples of classical probability problems besides rolling dice. These examples include flipping coins, drawing cards from a deck, guessing on the multiple choice test, selecting jelly beans from a bag, and choosing people for a commit. And now, let's we exercise. Question 1. A die is rolled. Find the probability that an even number is obtained. Solution to question 1. Let us first write the sample space S of the experiment. S equal 1, 2, 3, 4, 5, and 6. Let E be the an even number is obtained, and write it down. E equals 2, 4, and 6. We now use the formula of the classical probability. PE equals NE divided NS equals 3 divided 6 equals 1 divided 2. Question 2. Two coins are tossed. Find the probability that two heads are obtained. For the note, each coin has two possible outcomes: H, heads, and T, tails. Solution to question 2. The sample space S is given by S equal HT, HH, TH, and TT. Let E be the even two heads are obtained. E equals HH. We use the formula of classical probability. PE equals NE divided NS equals 1 divided 4. Question 3. Two dice are rolled. Find the probability that the sum is A equal to 1, B equal to 4, and C less than 13. Solution to question 3. For A, the sample space S of two dice is shown below. As you guys can see, the S. Let E be the even sum equal to 1. There are no outcomes which correspond to a sum equal to 1. PE equal NE divided NS equals 0 divided 36 equals 0. And for B, three possible outcomes give a sum equal to 4. E equals 1, 3, 2, 2, and 3, 1. And PE equals NE divided NS equals 3 divided 36 equals 1 divided 12. And for the C, all possible outcomes. E equal S give a sum less than 13. And PE equals NE divided NS equals 36 divided 36 equals 1. So thank you guys for watching. Hope you guys enjoy our discussion about classical probability, and see you